Good afternoon, everybody. Today we will discuss the structure of IF5 molecule. Uh, the you know that the atom which having larger in size is the central metal atom in every interhalogen compound. So in IF5, the iodine is the central metal atom. See the electronic configuration of the iodine. It is 5 5s2 and 5p5, and you know that d orbital are present in iodine and the d orbital is completely absent, completely empty, and we have to create 5 if covalent bond. For that we have to excite the electron in the p orbital to the d orbital in order to form the bond between the iodine and the fluorine. So the 3 of the electron, the 2 of the electron in the p orbital is excited into the 5d orbital. So the 1s orbital and 3p orbital and the remaining 2d orbital undergo the hybridization, and we will get 6sp3d2 hybridized orbital, and each hybridized orbital combine with the fluorine atom and to form the octahedral geometry. Since there is a one lone pair of electron, it is exists in the axial position. The actual geometry of the IF5 is square pyramidal. Now we are moving into the another interhalogen compound, that is IF7. See the general electronic configuration of the iodine. It is 5s2 and 5p5 3d0. In order to form the 7 IF bonds, we have to excite the 2 electron in the p orbital in the 5d orbital, and also one more electron in the 5s orbital is also excited into the 5d orbital. So every orbitals in the excited state are half filled, and these orbital undergo the hybridization and to form sp3d3 hybridization, and these sp3 hybridized orbital combine with the fluorine atom and to form IF7. See the geometry of the IF7, it is pentagonal bipyramidal, and we are normally the 5f orbital exists in one plane and the f atom which is exist in the axial are perpendicular to this plane. So normally we are expecting the bond angle is 90, and in axial geometry also the bond angle is 90, and the bond length between the iodine and fluorine in axial position and equatorial position is entirely different. In axial position we have the bond length of 179 picometer, whereas in the equatorial position we have only 186 picometer. Now the angle between the two fluorine atoms in the equatorial position is only 72 degree. Whereas in the IF5 we can see that the bond angle between the plane of the fluorine atom which is in equatorial position and axial position, the angle between the equatorial and axial position is only 81.9 degree. This is mainly due to the repulsion of the lone pair of electron which is exist in the axial position. Now we are moving into another topic, that is pseudo halogen compound. Certain mono-negative group resembles halide ion in character. They shows the similarity, at the same time the differences. Some examples are Cn minus ion, SCN minus, OCN minus, etc. Then now we are moving into the similarity between the pseudo halogen compounds and halogen. You know that every halogen are gaseous in state and they are diatomic. Similarly, pseudo halogen are volatile gas like halogen, and they are dimeric and they react with alkali. You know that the chlorine gas react with KOH and to form the KCl. Similarly, the pseudo halogen also react with alkali. And cyanide and pseudo halogen add across the double bond or the triple bond or any multiple bond. This is mainly due to halogen, we can easily add the halogen in the multiple bonded compound. Similarly, the pseudo halogen compound also can add in the multiple bond. And pseudo halogen react with halogen and to form the covalent bond. And the pseudo halogen undergo the thermal and photochemical dissociation as similar to the halogen. And pseudo halogen forms monobasic acid similar to the halogen HX, and all the acid are weak acids. And pseudo halide salts of heavy metals are insoluble or sparingly soluble in water. And it forms pseudo halogen compound also form the complexes, several complexes. Now we are moving into the differences between the pseudo halogen compound. It has a tendency to polymerizes, whereas the halide has no tendency to polymerize. And every acid of every acid of HX, where X is the pseudo halogen, are weak acid, whereas the halides form strong acids. And every pseudo halogen R exists as an ambidentate ligand. That means it can combine with the metal both of the atom. But halogen could not be act as an ambidentate ligand. Now, the halogen have a capacity to back donate the electrons to the metal in the organic molecules in the coordination compound, whereas the interhalogen compound could not. The pseudo halogen compound could not. And pseudo halogen compounds are strong ligands and they are yielding low spin complexes. Thank you.